Okay, like we talked about, if we have two polynomials and the divisor is linear, we can use a different technique to divide them. It's called synthetic division. There's some explanations in the book that are pretty good, but I think what I'll do, I'll go right to an example and we'll see how to set it up from there. So let's look at let's look at this problem here. Now, the first thing you notice, exponent of 1 here, so this is linear, so we can go ahead and use synthetic division. The way it works is this. Here's the setup. We're going to put the root here, and if you look at this, the root is when this equals 0. That would be at x equals minus 3, so that goes here. So you always put the root here. What you put across here at the top are the coefficients of the dividend, and again, just like before, you got a 0 fill. So the coefficient here is just 1. Coefficient here is minus 7, but we're missing x squared, so I got to put a 0 in for x squared. For x, it's minus 7. And then for the constant term, it's just 6. That's all there is to it. And then they always start the same way. Bring down whatever the first guy is, happens to be a 1 here. Multiply this times the root, so it's going to be 1 times minus 3, that goes here. And then everything's added. 0 plus minus 3 is minus 3. Okay. Again, we're ready to multiply. Minus 3 times minus 3 is a positive 9. Add them up. 9 and minus 7 is plus 2. Again, multiply. 2 times minus 3 is minus 6. Add them up. 6 minus 6 is 0. That's where we end. That's your remainder right there. And the quotient is here. And since it was x cubed and we're dividing by x, we're always going to drop down 1. So this will be 1x squared minus 3x. And then plus 2. So that would be your answer. Very easy to get. A couple things to note. Number one, the remainder was 0. What does that mean? That means that that is a factor. It would factor out evenly. And it also means then that minus 3 is actually a root, okay, of this equation. Right, let's look at another equation in the book, or not an equation, but a theorem. This is called the Remainder Theorem, and it'll use synthetic division. All right, so what is the Remainder Theorem? Remainder Theorem basically just says if I have a polynomial function and I evaluate it at c, in other words, I would plug c in here and I would do all the work and get some answer. That's going to be the same thing as, we'll just say it equals the remainder using synthetic division with c as the root. So let's see how it works. I'll do an example, but quickly, up here, the way it would work is if that was p of x there, and I had minus 3, p of minus 3 should just equal 0. And we can verify that real quick. Minus 3 cubed minus 7 times minus 3 plus 6. That's minus 27 plus 21 plus 6. If you add all that up, it equals 0. So it looks like the theorem works. That's how it works. Now, this is pretty simple. Let's try one a little more interesting. Let's find f of minus 5 if f of x is going to equal this. Okay, so we already know how to do this. We could go ahead and plug minus 5 in all of these and then do all these exponents and then add and subtract all that stuff. And that's not that big a deal, but it is some work. But let's try the remainder theorem. With the remainder theorem, it just says use synthetic division. So we're going to use minus 5. We're going to put our coefficients in. 1, 3, minus 8, 5, and minus 6. And then we're going to start the process. Bring down the first one, multiply, add, multiply, add, multiply, add, multiply. That's going to be a positive 25. Then add. That's our remainder. So rather than plug this in and do all that work, f of minus 5 equals 19. So you can get it that way. It's pretty nice. One other thing we can do, we can kind of use the remainder theorem to see if a particular number is a root. So again, remember that if I put a particular value in for x and the whole function equals 0, then that means it's a root, right? Because when y equals 0, we're on the x-axis. So we can use a remainder theorem to see if we have a root. So let's try that. So let's say I suspect minus 3/5 is a root of a particular polynomial. So to test that, all I need to do is put in, I could put that in here and see if I wind up getting 0 as an answer. Let's call this f of x. But again, that's a lot of work. I'm plugging a fraction in here, it's negative, I got to cube a fraction, square a fraction, all that stuff. Or I can just use the remainder theorem to see if I get 0 as an answer. So minus 3/5 is my root. Here's my coefficients. Again, I have all the powers of x, so I don't need to zero fill here. Whoops, minus 9. Okay. Again, draw your line. They always start the same. Bring the first one down, and then start multiplying. Over here, when I multiply, the 5s are going to count, so I'm just going to get minus 3. I add these up, that's 10. This time when I multiply, the 5 will cancel and leave a 2 here, so 2 times minus 3 would be minus 6. Add those up, that's a minus 15. Okay, this time when I multiply these two, the 5 would cancel, leaving a 3 here. 3 times 3 is 9, but it's a negative times a negative, so that'd be a positive 9. Add these up, that's a 0. Guess what? F of minus 3/5 equals 0. Minus 3/5 is a root. And that's it for part 2. Next, we're going to find some other methods here for working with polynomial functions. We'll get to that in just a minute.